In this tutorial, we are going to discuss application of integral, or we can also say that area under curves, right? So now this is our 8th chapter, area under curve. In this chapter, we will discuss about how to find the area under some different curves, either area of triangle, area of some different curves, area of parabola, circle, ellipse, hyperbola, different kinds of things. But before starting this chapter, you must know about the graph. How can you draw the graph of signum function? How can you draw the graph of parabolic function, elliptical function, circular function, linear function? You must know about the graph of the function, right? As we discussed in the first chapter, functions, in which graph of the function, right? Now, how can you find area under any curve? Let us see the basic concept of this chapter. This is very simple chapter. This is also called the application of integration, as we discussed in the limit of the sum in definite integral. Let us see, we have a curve. Let us see, we have a curve, this one, and we have to find area of this portion. Let us see, this curve is called y equal to fx, and on x-axis these points are called a0 and b0, and we have to find area of this part. Then how can we find the area? We can find the area by integration method. We can find the area by integration method. How can we find the integration method? Let us see, the area of this part is attached with the x-axis. So we can take a very small part on the x-axis. We can take this very small part on the x-axis. Let us see, this is a very small rectangle, as we discussed in the limit sum method. Let us consider this small part on the x-axis as dx or delta x. Delta x means very small change in x. Let us consider this as dx. Now we can find the integration. Now we can find the area of this part. Integration means what? Summation. So we can find the area of this part, this part, this part, this part. We can add all the parts. We will get the area of complete shaded region. So we can say that, let us see, we considered it as A, B, C, D. So area of A, B, C, D, A. If you have any curve in some bounded region, so you must write the final point and initial point, both must be same, right? The area of ABCD is what? Quadrilateral. But we have curved part also in this area, so we have to write the area as ABCDA, right? So now how can we find the area? First we have to put the integration with lower limit and upper limit. So we can write it as A to B, lower limit A up to upper limit B in x-axis, right? And what is the function? And function fx. Fx with respect to x. Why? Because the very small part is called dx. Now by integrating this factor as definite integration, we can find the area in square unit. Now this curve is lying on the x-axis, right? This area is attached with the x-axis. But if any question, let us see. If we have a coordinate axis and we have a curve like this one, like this is the curve, then the question is, how can you find area of this part? How can you find the area of this part? The question is, how can you find area of this part? And this is the curve. This curve is called y equal to fx. And let us consider this part, this point on the y-axis is called 0, a and 0, b, right? Now how can we find the area of this part? Again, this area is attached with y-axis. The concept is what? First we have to search the area attached with either x-axis or the y-axis. Now we can take very small part on the y-axis. Now we can take very small part on the y-axis. This part is called dy, right? So how can we find the area? Now this part, this complete length is called x, and this part is called dy. So we can find the area that is called x multiplied dy. There is very small rectangle in this. Very small rectangle, small rectangle, small rectangle. Many rectangles are there. So the area will be integration of x dy, right? So here, area of the shaded region can be written as integration of limit a to b dy. Will be written here dy. So you must write the function y in terms of x. Sorry, x in terms of y. We have to write the function x in terms of y. So we can write the function as y x dy, right? Now we have to write this function x in terms of y, then we can put the value in terms of y. Y is the function here. So this is the area. If area is attached with x-axis and the area attached with y. Let us see one example for this. Let us see one example for this. If we have a question, find the area. Let us see, find the area bounded by a parabola y square equal to 4x. Find the area bounded by a parabola y square equal to 4ax, x is equal to 0 and x is equal to 2. Right? We have to find the area of this part. Area bounded by these three curves. Here, three curves. So now first we have to draw the diagram. Graph is very important in this chapter. You must know how to draw the diagram, how to draw the graph for parabolic function, elliptical function, straight line and all the things. Then we can find the area. So first we have to draw the graph for all the three curves. Let us see on the coordinate axis. On the coordinate axis, if we have a coordinate axis xy. Now, what do we mean by y square equal to 4x? Y square equal to 4x means this is a parabola whose vertex is origin and this is along positive x-axis. As we discussed earlier in class 11th also, y square equal to 4x, that means positive x-axis along with positive x-axis. X square equal to 4ay is along positive y-axis. Y square equal to minus 4x is along negative x-axis, right? And this is the curve y square equal to 4x. And this line is called x equal to 0. Because you know y-axis is called x equal to 0. And what do we mean by x equal to 2? Let us see this pointing 2 on the x-axis. So this straight line parallel to y-axis is known as x equal to 2. Now the question is very simple. We have to find the area bounded by these three curves. Now what is the area bounded by these three curves? Area bounded by this straight line and this curve. The area bounded can be shaded as this one. Now this is the area, right? Now we have to find area of this region. So how can we find the area of this region? Let us consider these points as A, this point as B, this point as C. Right? So first we can find the area of OACO. We can find the area above x-axis and twice of this we will get the required area. So first we have to find the area of OACO, right? First we have to find the area of OACO. We can find the area under this curve. The curve is what? Y square equal to 4x. And this area is attached with what? X-axis. We can take very small part on the x-axis and this part is called dx here. We can find the area of OACO and twice of this will get the complete shaded area of the complete shaded region. It's very simple. Now how can we find this area? We can using integration method to find this area. Let us see if we have to find the area of this part. So we can say that area of the region OACO. The area of region OACO can be written as integration of. Now it's very simple. We have to find the lower limit and upper limit of the total area. And here the lower limit on x-axis was 0 and the upper limit was 2 because this line is called x equal to 2. So this point is called 2, 0 and this point is called 0, 0. So on x-axis the lower limit is 0 and the upper limit is what? 2. Right? Lower limit is 0 and upper limit is 2. And the curve is what? Y square equal to 4ax. And the question is, this is very small part dx, so we can write it as y dx. Right? This is the area. So integration of 0 to 2. How can we represent y dx? We have to write y in terms of x here. Y in terms of x can be written as y equal to 2 root x. When y square equal to 4x, then y can be written as 2 root x. It can be written as 2 root x dx. Now after integrating, we will get the area of this part above x-axis. You will get 2 multiply 0 to 2 root x dx, right? Now you can find the integration of this. You know, the integration of root x is x to the power 3 by 2 divided by 3 by 2. And the limit is 0 to 2. Now, you can write it as 4 by 3 after taking 3 by 2 outside this one, this bracket. After reciprocal, we get 4 by 3 and we can put 2 here, 2 to the power 3 by 2 minus 0, right? So, you get 4 by 3 multiplied 2 to the power 3 by 2, right? Square unit. Square unit. We can also simplify this one as 4 by 3 multiply, 2 to the power 1 by 2 is root 2. So we can write it as root 2 to the power 3, right? Finally, root 2 to the power 3 can be written 2 root 2. So it can be written as 8 root 2 by 3 square units, right? Square units, right? Very good. Now root 2 to the power 3 is equal to root 2 multiply root 2, root 2. And 2 multiply 4, 8 root 2 by 3. This much square unit. Now, we have to find the complete area of the shaded region. So, therefore, area of the shaded region can be written as 2 multiply area of the region OACO. So, we can write it as 2 multiply 8 root 2 by 3. You will get 16 root 2 by 3 square units, right? By this way we can find the area of any bounded region by integration method. Now the very important concept of this thing is, first we have to find the area attached with either x-axis or y-axis. It's a very simple concept. If area attached with x-axis, we can integrate y dx from lower limit to upper limit. And if it attached with y-axis, we will get integration of x dy and the limit on the y-axis from lower limit to upper limit, right? So this is the concept of area under curve, right? Now we have some very important question to find the area. Either question related to one curve or more than one curve, right? If the question related to one curve, this type of question, you can find the area of the circle, you can find the area of the parabola, ellipse, and in two curves, bounded by the two curves, we can find the area of a parabola with circle, area of two parabola bounded with two parabola, two circles, one ellipse with parabola, and all the things. Also, we can find the area of some modulus function, right? Now, let us consider some very good example for this. Let us consider some very good example for this. And this is very important question. Already asked it 3 times in board examination. The question is, find the area. Find the area bounded by the curve x square is equal to 4y and the line x is equal to 4y minus 2, right? So now in this question we have a parabola with a straight line. We have a parabola with a straight line. So the very important thing in this question, how can we draw the graph? If you know how to draw this graph, then you can find the area very easily, right? Let us see. We have a parabola x square equal to 4y. Now you know how to draw the graph for x square equal to 4y. X square equal to 4y means this parabola is along positive y-axis. So the graph of x square equal to 4y is passing through the origin, and this is the parabola like this. This is the graph called x square equal to 4y passing through the origin, because if you put x equal to 0, then y becomes 0. Very simple. Now, how can you draw the graph for x equal to 4y minus 2? You know how to draw the graph for a straight line? Very simple. If you put y equal to 0, then x equal to minus 2 means this graph goes through minus 2 on x-axis, right? Minus 2, 0. And if you put x equal to 0, then 4y equal to 2 and y equal to 1 by 2. Here the y equal to what? 1 by 2. We can take this point is 0, 1 by 2. Now, this straight line intersecting x-axis at minus 2, 0 and y-axis at 0, 1 by 2. Now we can draw this straight line like this. Very simple. Very simple question. Now we draw the graph for the parabola and the straight line. Now the question is, what is the bounded region? The question is, find the area of the bounded region. So we have to represent, we have to set the bounded region of the straight line with parabola. I think this is the bounded region with straight line and parabola completely. Straight line and the parabola. This is the bounded region. Now we have to find the area of this bounded region. So we can consider some points here. We can consider A, B, C, right? So now we can find this area into two parts here. You can find the area into two parts here. Now this area is attached with y-axis, but we can find the area with x-axis also. Let us see. If you draw the perpendicular here and perpendicular from point A also, we have to find the limit. Now you know this point is 0, 0. Now we have to find this point and this point on the x-axis. Then we can find the area, right? It's very simple concept. If we consider this point as point P and this point as point Q, let us see. If you discuss this point as point Q and this point is minus 2, 0. Now we can find the area like find the complete area of QPAC. Find the complete area of the quadrilateral QPAC and subtract these two areas from them. We'll get the area of the required region. Now let us see how can we find this area. It's very simple concept. You have to find the area of settled region, means you have to write the area. So we have to find the area of this complete shaded region. So we can find the area of QPAC. To find the area of QPAC, we must know the point Q and point P. What do you mean by point Q and point P? The point Q is the x-coordinate of point C and point P is the x-coordinate of point A. Now how can we find this point? We can solve these two equations to find two values of x that are the x-coordinates of point A and point C, because this point A is the point of intersection of these two curves. And this point C is also the point of intersection of these two curves. So we have to solve this to find the point of intersection. Then we can know about what are the points of x, q and p. Let us see. X square equal to 4y and x equal to 4y minus 2. So second equation can also be written as x plus 2 equal to 4y. Now we can equate both the equation. 4y equal to x square and 4y equal to x plus 2. So therefore we can equate the right hand side, we will get x square equal to x plus 2. You will get x square minus x minus 2 equal to 0. Now we can find the value of x here. X square minus 2x plus x minus 2 equal to 0. You will get 2 factor x minus 2 and x plus 1 equal to 0. Now x equal to what? 2n minus 1. X equal to 2n minus 1. Now we can say that the coordinate of point Q is minus 1 comma 0 and the coordinate of point P is 2 comma 0. Right? So these are the points on the x-axis. These both are the points on the x-axis. Now, what is the shaded region? Let us see. Area of the shaded region. Area of the shaded region can be written as area of complete QPAC. This is the quadrangle minus area under curve QOCQ and minus area of OPAO, right? Now we have to find the area of the quadrangle QPAC. So first, the very important thing in area of QPAC is what? What are the lower limit and the upper limit? Here in the area of QPAC, the lower limit is minus 1 and upper limit is what? 2. So we can find the area of QPAC at the limit minus 1 to 2. And what is the curve? What is the curve? What we have to find? Area under this straight line. Area under this straight line, and this straight line is called x equal to 4y minus 2, right? So we can write y in terms of x. You will get x plus 2 by 4. So we can write it here x plus 2 by 4 dx minus. Now how can we find the area of QOCQ? Now we have QOCQ, very small part. And in the area of QOCQ, what are the lower and the upper limit on x-axis? That are minus 1 and 0. That are what? Minus 1 and 0. So in this integration, we can put minus 1 and 0 here. Right? Minus 1 and 0. Minus 1 to 0. And what is the curve in this? This is the curve. We have to find the area under this curve. And this curve is called x square equal to 4y. And y in terms of x can be written as x square by 4 with respect to x, right? Now the last is area of OPAO. Now this is the area of OPAO. How can we find area of this one? So first we have to write the lower limit and upper limit on x-axis. For this area, the lower limit is 0 and the upper limit is 2. So we can write it here 0 to 2. And the curve is same. Curve is what? This is the curve. This is the curve. And this curve named as x square equal to 4y can be written as x square by 4 with respect to x, right? It's very simple. Now we can integrate this function to find the complete area. We can take 1 by 4 common. And the very important thing in this chapter, this topic is, we cannot apply the property of definite integral in this integration. We cannot apply the property of definite integral. Why? Because you know the area below x-axis is negative and the area above x-axis is positive. So it is not possible to apply the property of definite integrals. We can find the integration of all the three parts separately and then simplify. We'll get the exact answer. So we can take 1 by 4 common. Now we have minus 1 to 2 x plus 2 dx minus integration minus 1 to 0 x square dx and minus integration of 0 to 2 x square dx, right? Now we can solve this integration. Very simple question. You can solve this integration by fraction addition or fraction subtraction. You will get the area in square unit, right? So this is the area bounded two curves. One curve is a parabola, another curve is a straight line. It's very simple. Now you can also find the area between two circles, area between two parabola, area bounded by one ellipse with parabola, one parabola with circle. Right? Now let us do one more question related to this. The question is, this is also a very important question. Find the area of the region. Find the area of the region, and the question is XY such that y square is less than or equal to 4x and 4x square plus 4y square is less than or equal to 9. Right? It's very simple. Now we have two curves in this. First we have to draw the graph and set the region. If you are able to draw the graph and set the region, you can find the area. It's a very difficult question, I think so. How can you draw the graph of inequality? We have two inequality in this. One in terms of parabola, other in terms of circle. We have two inequality, not an equation. But we have to find the curve for equation only. To find the set region, we have to use this inequality, right? Now, first we have to draw the graph for y square equal to 4x and 4x plus 4y square equal to 9. Then we can set the region, feasible region, right? Now let us see on the coordinate axis. First of all, we have to draw the graph for y square equal to 4x. First we have to draw the graph for y square equal to 4x. You know y square equal to 4x is a parabola along point x-axis? Yes. So first we can draw the graph of the parabola on the point x-axis. On the point x-axis. Now the second thing is 4x square plus 4y square equal to 9. What is this 4x square plus 4y square equal to 9? What is this? Is it ellipse? Is it circle? Is it hyperbola? If you take 2, 4 common in the left hand side and 5 in the right hand side, you will get x square plus y square equal to 9 by 4, that is 3 by 2 whole square. Yes, very simple. It is circle. You know the general equation of circle? X minus h whole square plus y minus k whole square equal to r square. Now we have a circle. This is x minus 0 whole square plus y minus 0 whole square equal to 3 by 2 whole square. So we can say that this is a circle of center 0, 0 and the radius is 3 by 2. Center 0, 0 and the radius is 3 by 2. So we have to draw a circle with central origin and the radius is 3 by 2. Let us see. Before drawing this one, first we have to find the point of intersection where it intersects with this parabola. Let us see. We have to solve this equation with this equation to find the point of intersection on x-axis, then we can draw the graph exactly. In any graph, first we have to find the point of intersection of these two curves. So we can equate y square with y square in both the equation. You will get x square minus 9 by 4. This is the value of y square in the second equation, and the value of y square in the first equation 4x, right? 4x is equal to 9 by 4 minus x square, right? Y square in the first equation 4x and the y square in the second equation 9 by 4 minus x square. Now we have a quadratic equation x square plus 4x minus 9 by 4 equal to 0. We have to find the value of x here. Yes, now we can take 4 as LCM. You will get 4x square plus 16x minus 9 is equal to 0. Now how can you find the area of this one? 4x square plus 16x minus 9, we have to split 9 multiplied 4, 36. Either or we can apply the quadratic form, and this will get minus 16 plus minus the square root of 256 plus 16 9 is 144 divided by 8. We can write it as minus 16 plus minus root 400, that is 20 divided by 8. So there are two values of x. We can say that 20 minus 16, that is 4 by 8, 1 by 2, and the second one is minus 60 minus 20 is minus 36 by 8. This one is minus 36 by 8. Now we have two values of x. Now we know the point of intersection of this one, right? So now the point of intersection is 1 by 2 on the positive side. So we can draw this circle like this one. We can draw the circle as center, origin, and the radius is 3 by 2 comma 0. You know the radius of the circle is 3 by 2, and the point of intersection is 1 by 2, 1 by 2. This is the point of intersection 1 by 2. So we can say that this point of this point is 1 by 2 comma 0. This is the point of intersection. We can represent it as A, B, and P, right? So what we have to find is find the area of region y square is less than equal to 4x. Now the very important thing in this question, how can we represent the shaded region? Now the very important thing, there are 2 points, there are 2 parts of the parabola. One is interior of the parabola, other is exterior of the parabola. Interior of the parabola and exterior of the parabola. Let us consider, let us put a point in this. Interior of the parabola is 1 by 2, 0. We can put here 1 by 2, 0. 0 is less than 4 multiplied 1 by 2. Yes, it satisfies. Means the area is interior of the parabola. And the exterior of the parabola is what? 0 comma 3 by 2. Is it satisfied? 0 comma 3 by 2. 0 comma 3 by 2. 3 by 2 is not less than 0. So exterior of the parabola not satisfied. So interior, we can consider interior of the parabola, not exterior of the parabola. And what about the circle? What about the circle? Circle, there are 2 parts in the circle. One interior to the circle, other one exterior to the circle. Interior to the circle is 0, 0. You can put 0, 0, get 0 plus 0 less than 9. Yes, this satisfies. So we have to take the area inside the circle, not outside the circle. Because outside the circle is not satisfied here. So we can take the area inside the circle. Inside the circle and inside the parabola. So what is the combined complete region? This is the region which we have to find. We have to find area of this complete region, right? We have to find area of this complete region. So now we can divide this region into 2 parts. First part is OBAO, and twice of this area will get the complete area. So this we have to find in 2 parts. First area of this part and second area of this part, right? So finally, let us see how to find the area of complete shaded region. So area of shaded region can be written as A 2 multiply, we can write it as 2 multiply area of the upper part, area of above the x-axis, OBAO. Area of OBAO. Now to multiply. How to find the area of OBAO? We can split area of OBAO in two parts. First and second. The first part is called area of the region OPAO and plus area of the region PBAP. Right? So to multiply. Now we can find the area of first part, that is OPAO and PBAP. So first thing is, what is the lower limit and upper limit of OPAO? 0 to 1 by 2, 0 to 1 by 2, and the curve is this one, and this curve is known as y square equal to 4x. This is the curve, this is the curve. We have to find the area under this curve from 0 to 1 by 2. So we can write the integration 0 to 1 by 2, and y in terms of x can be written as 2 root x dx plus integration of. Now the second thing, we have to find the area of PBAP. PBAP. How can we find the area of PBAP? Lower limit 1 by 2 to upper limit 3 by 2. So we can write the lower limit 1 by 2 to upper limit 3 by 2. And what is the curve? And the curve is circle. Under this circle, we have to find the area under this circle from 1 by 2 to 3 by 2. Under this circle. Right? Under this circle. Under this circle. And the circle is named as 4x square plus 4y square to 9. We have to write here y in terms of x. We'll get y in terms of x, that is square root of 3 by 2 whole square and minus x square with respect to x. Now you know how to integrate this function as well as this function. In this case, we have to apply the integration of some special form. You can refer the previous topics. Integration of some special form, integration of square root of a square minus x square dx. By that formula we can find the integration of this, then we can put the limit. You can solve this integration to get the area, right? So this is also very important question in terms of inequality. If we have a question in terms of inequality, we can equate this to find the diagram, to draw the graph, and then to set the region we need to use this inequality, right? So these are the basic concepts related to area under curve. Now we'll do some more questions related to area under curve in the next class. We'll do some more questions related to like two circle or two parabola and all the things like modulus function in the next tutorial. Thank you.